have an electron accelerated from rest through a potential difference of 1800 volts. What is its speed? Potential difference is delta V. Not working very well. So delta V is 1800 volts. That can be a little confusing, by the way. We use V as the symbol to represent potential, and V to represent volts, the units of potential. Whenever a charge moves through a potential difference, its potential energy is going to change. Potential energy change is equal to the charge that's moving through the potential difference times delta V. So the potential energy change, we have Q for an electron is negative 1.6 times 10 to the negative 19 coulombs. Our delta V is 1800 volts. So delta U is negative, which should make sense if the charge is accelerating, going faster and faster and faster, then its potential energy should be decreasing. The kinetic energy increasing had to come from somewhere. So an increasing kinetic energy correlates to a decreasing potential energy. So that's how much the potential energy will change by for this electron. Now, taking this back to conservation of energy, we know delta K, the change in kinetic energy, is equal to negative delta U. Negative sign means as one increases, the other one decreases. So our change in kinetic energy is going to be negative. Delta U is negative 2.88 times 10 to the negative 16 joules. Negative signs cancel, so delta K is positive. Its kinetic energy is increasing. Kinetic energy, 1/2 mv squared, so 1/2 mv final squared minus 1/2 mv initial squared. That's what we mean by change. But it was accelerated from rest, so the initial kinetic energy is 0. So our final speed, bring the 2 over, divide by the mass in one electron, 9.11 times 10 to the negative 31 kilograms. Square root it. The final speed of our electron is 2.5 times 10 to the 7th meters per second. It's not that bad. Only a little fast.